Hi everyone, this is Saad Aslam. I hope you are all doing well. So today we are going to discuss another LeetCode question, that is how to implement stack using queues. So in the previous video we have discussed how to implement queue using stacks. This question is like quite similar to that. I'm linking the link of that video in the description too. You can go and check out the video too. So let's first discuss the problem statement of our today's question. So it is a 2 to 5 number LeetCode question, that is implement stack using queues. So you have to implement a last in first out stack using only 2 queues. There is a limitation that we can use up to 2 queues. Okay, we can have a limitation of that. So the implemented stack should support all functions of a normal stack. Like it have to support the push, pop, top, and empty function. So implement the MyStack class. We have to implement the functions given on the right side of the screen. Like it is, we have to implement the push function. We have to implement the pop function, top, and empty function. Okay, so void push, pop, top, and empty. So push basically will add the element at the top of the stack. Pop will remove the element from the stack and return it. Top basically will remove the element that is at the top of the stack, and empty will return true if the stack is empty, otherwise it will return false. Okay, so we have to implement these functions. There are a couple of examples given here. Let's try to understand these examples in our whiteboard section. So before moving on, if you haven't subscribed to my channel, make sure to hit the bell icon and all of the usual stuff. So now let's go to our whiteboard screen. Okay, so here we are in our whiteboard section. We'll discuss the approach of it, and after that we will discuss the implementation of our code in Java, and we'll quickly implement it in C++ too. So let me just, okay. So on the left side of the screen we have queue. So it is like, let me just, so here we have queue, and on the right side we have stack. Okay, so basically queue uses the first in first out approach. Okay, like it uses the FIFO approach. Here you can see on the example, like there is an element that is added at the back, that is the in queue operation, and the element is removed from the front, that is the dequeue operation. That is element that is added first will be removed first. But on the other hand, stack is a LIFO, follows a LIFO approach, like the element that is added at the last will be removed first. Okay, here you can see the element that is added at the top of the stack is removed from the top first. Okay, so we have to implement this LIFO approach using this queue FIFO approach. Okay, so this is the difference between queue and stack. We have to implement stack using the queue. Okay, so let's take an example to understand it more deeply. Okay, so suppose let's first implement this input using simple stack or queue. Okay, so suppose this is our queue. Okay, this is our queue. Okay, so first we push the element 1, this operation. Okay, so the element will be added here. Next our push will be added at the push 2 will be added at the back. Okay, so currently our queue is something like this. The next operation is top. So top, basically top will return the element that is at the, you can say, front. So currently top is this, so top will return 1. Now pop. So pop basically what we'll do is like pop will return the element at the front too and also remove it. So first it will, you can say, remove 1, okay, and also return it. So currently our output is something like 1 1 and 1 1. Okay. So our top is now pointing to 2. So currently our top is currently 2. Now the next operation is push 3. So push will be added here. The next is push 4. 4 will be added here. The next operation is top. So what is at the top? So top is currently at 2. So it will return 2. Our next operation is pop. So pop will also remove the element and return it. So this is our queue. Okay, so queue, after, like, this is the operations using queue, like it has the output of 1 1 2 2. So now let's try to implement this using stack, like how this stack behaves in this input. Okay, so let's quickly make a stack here. Okay, so stack is something like this. Our first operation was push 1. Okay, so it will return push 1. The next operation was push 2. Okay, and the next operation was top. So top, what will return? So top currently return the top. So top is 2. Okay, the next operation was pop. So pop will remove it from the stack and also return it. So it will remove it from the stack and also return it. So output is 2. Our next operation was push 3 and push 4, and the next operation was top and pop. So top will return the element that is at the top. So currently the top is 4, and for push pop, basically it will remove it from the stack and also return it. So the output will be something like this. Okay, so the currently with queue the output was 1 1 2 2, but with stack the output is 2 2 4 4. So the output is different. So we have to implement this stack using the behavior of a queue. So let's understand how we are going to modify the queue to implement or behave like a stack. So let's try to discuss that. Okay, so for this we have to modify our push operation in our queue to modify and to behave it like a stack. The other operations will remain the same. So for the push function, suppose the push function in a queue. Okay, so suppose this is our queue. So we have to follow these operations in our push function. So suppose let's take the same example above, like first we have push 1, and the next was push 2, the next was top and pop, and similarly push 3, push 4, top and pop. So these were the operations in the previous example. So first push 3, first push 1. So we will, as in our steps, we have to push 1. Okay, the next is we have to find the size, queue size -1. So currently the queue size is 1 and -1. So currently here we use queue size. It is the size of the queue. So currently the queue size is 0. Okay, so while size minus is greater than 0, so currently size is not 0, so it will skip this part. Okay, so for the next operation push 2, like this, for this push 1 we are not going in the loop. So okay, so the next operation is push 2. So what we are going to do, first we are going to push it in the queue. so we are going to push it in the queue, and we are going to check the size of the queue. So size is queue, currently the size is 2 minus 1, so the size is now 1. Okay, so as size is not 0, so we are going to go in our while loop. So for the while loop, first we'll check the element that is at the front, like queue dot front. So currently the element at the front is 1. Okay, so this is the 1, and we are going to first like we have stored the front in the topmost element in our top variable, and after that we are going to pop. So like the element is currently our top is this, like suppose top is 1, and we'll pop. So for pop, we'll remove it from the queue. Okay, so now we have removed that element from the queue. Now we are going to push that top element in the queue. So when we are going to add the element, it will be added at the back. So the top is 1, and we are going to push it in the queue, so it will be added here at the back. Okay, so currently our queue is something like this. Okay, this. So for push 2, our operation is completed. Our next operation is top. So what will top return? So basically top will return the element that is at the front. So currently the element at the front is 1. Okay, so top operation is completed, and for pop, it will remove from the queue and also return it. Okay, sorry, the element at the front was 2. Let me just this. Okay, so for like top, the element at the front was 2, and for the pop, it will return the element from the front and also remove it from the queue. So it will return it and also remove it from the queue. Okay, so currently our top is at 1. Next, our operation is push 3. Okay, push 3. So what we'll do, like first push will be added at the back 3. Okay, and next it will check the size. The size is currently 2 and minus 1. Currently the size is 1. Okay, and at the top we have 1. Okay, so the size is 1. Okay, we have calculated the size. Okay, and at the top we have 1. Okay, so first we'll add 1 in our variable top, and we will remove it from the queue. Like suppose we are going to remove it from the queue, and we are going to add it back in the stack. Sorry, back in the queue. Okay, so for this push we are going to add this. Okay, so we have completed our push 3 function. Now our next function is push 4. So for push 4, it will be added back here. Okay, and it will check the size. So currently the size is 3 and minus 1. So currently our queue's size is 2. Okay, our queue size is 2, and what is at the top? So at the top currently we have okay, so currently at top we have 3, so our top will be 3. So top will be first added in the top variable, and then it will remove from the queue and add it again. So we'll remove it from the queue. Okay, so we have removed 3, and so 3 will be added back. For this, here you can see we have -1, so for first the size will be reduced to for first the size is 2, and for the second operation the queue size will be reduced to 1, like for the size -1. So currently our queue size is not 0, so we are going to loop in the while loop. So what is again are at the top? So at the top we have 1. So first remove this, and our top is 1. So top will be removed from the queue and added in the back. So first we'll remove 1 from the queue and we'll add it again in the queue. Okay, so for push 4 our entire steps are completed. The next is top. Okay, so this. So what we'll do, like top basically will return the element that is at the front. So what is at the front? 4. And the next is pop. So pop will remove from the queue and also return it. Okay, so this. Okay, so the output is something like 2, 2 and 4, 4. So if you have noticed, the output is similar to the behavior we have implemented earlier with the stack. Okay, so let me just quickly go to the output. So what we have implemented with output. So here we can see earlier the output was same, 2244, and we have implemented the same output using a queue. So this is the approach of it, like the pop and the top functions will remain the same, but just we have to modify our push function. We are going to like check these steps. Like we are going to first add the element in the queue. We are going to check the size, and if the size is greater than 0, we are going to remove the element from the front and add it back to at the rear of the queue. So we have to perform these operations to make queue behave like a stack. So I hope you understand the approach of it. If you have any questions, confusions, you can let me know in comments. So now let's try to quickly implement this in our coding section. So let's go to our coding section. So here we are in our coding section. We first implement this approach in Java, and after that we will quickly implement in C++. So as discussed in approach, we are going to use a queue. Okay, so queue, and the type will be integer, and we are simply queue. Okay, we'll initialize queue new linked list. Okay, okay. So we are going to modify a push function. So first we are going to add the element in the queue. So queue dot add x. After that we are initializing a size variable that will check the size of the queue. So queue dot size and -1. Okay, while size minus is greater than 0, then what we will do, like we'll remove the element from the front and add it in the back. So queue dot add and queue dot form. Okay, I think that is enough for a push function. Now let's implement our pop. So we have to return queue dot fall, and for top we have to return queue dot peak, and for the empty we have to return if Q is empty. I think that's it enough for the implementation. Now let's quickly check our syntax error. Q integer, Q is equal new linked list, Q dot add size, pop, Q dot poll, Q dot thing. Okay, so let's run this code. Okay, the code has run successfully. Now let's try to submit this. Okay, the code has been submitted successfully. So that's the implementation of it in Java. I hope you understand the implementation of it. Now let's quickly implement this in C++. Okay, the idea same, the implementation is same, just the language difference. So Q. So here you can see the code has been run successfully in our C++2. There's a little tweak in our C++ code. Here you can see in Java we simply the Q.poll will do the magic, like it will remove the element from the queue and also return it. But in C++, Q.pop only removes the element. So for that we first have to store the variable store the variable using Q.front. Q.front basically will only return the element that is at the front of the queue, not remove it. And after that Q.pop will remove the element from the queue. So Q.poll is doing both of the operations of Q.front and Q.pop. So this is a quite little bit modification in C++. So now let's try to submit this. Okay, so here you can see the code has been submitted successfully. Okay, so I hope you understand the approach of it, implementation of it. If you have any questions, you can let me know in comments. You can reach me out on LinkedIn. I have a proper series going on these problem solving questions. If you haven't watched those videos, you can watch those videos as well. And see you in the next video. Bye bye.